Oke, so kita boleh mulai. Banyak mau setup because this laptop I seldom use, but jadi need to login into Microsoft and then setting everything. It's okay. So, okay, we continue with lecture 4. So this one is modeling 2, alternative set base. So if you recall back in the previous exercise, term document matrix itu dia mengandungi satu term saja. So that means it failed to capture computer science or software engineering, which consists of two terms. Okay? So another alternative is we use the set base lah, in which we consider more than one index to be collected in the term document matrix. Okay, so we will look into the set-based model. Okay, so the whole idea is we want to capture the term dependency, capture more than one term at one time. So the only way we can capture this is by capturing more than one index term. So for example, two terms together or three terms together. So by capturing this occurrence of more than one term, then we can look at the term dependency. Okay, so we introduce this called term set to capture the term dependency. So this approach will improve the retrieval result because in most of the cases, some of the terms always come together. Like for example, computer science, software engineering, and network engineering. So we have to look at that the possibility of having more than one term in our document. Okay. So the concept term set is introduced in which it will be replacing the index term. So in the previous lecture, we only consider one index term, right? So for this one, we use the set base in order to group single term to become term set. So in this example, they define that the term set may consist of all of these keyword A, keyword up to N, subset of the term in the collection. Okay, so if all index term in SI occur in document DJ, then we say that the term set SI occur in this one. So for example, if we say we have A, B, C, so this is the term set for term set A, B, C. Okay. So this one saying that we have A, B, C in our document. So this is if we say that this term set ABC occur in the document. Okay, so instead of having one character or one word or one index, look into the possibility, what if we count more than one index? Okay, so it all depends on the vocabulary size. So if we define the T as the vocabulary size, then we have the number of term set to be 2 to the power of T. Okay, so for example, if we have 3 unique term, so we could have up to 8 different combination. Okay, so the higher is the T, the bigger is the number of pattern that we have to look for the document. Okay, but in most combination, they do not carry any meaning, so the actual number of term set is actually smaller than this. Okay, So for example, if we have keyword 1, keyword 2, and keyword 3, and the number of pattern that we can have is supposed to be 2 to the power of 3. So yang set kosongnya pun masuk juga lah. So this is the number of pattern of the occurrence of keyword that we have in our term set. So ini dipanggil term set 1, term set 2, and so on. So until we have term set number 8. So this is term set. Okay. So let's suppose we have the pattern here S1 up to 2 to the power of t, where t refer to number of unique term set that we have. Okay, so the number of different pattern here is up to the power of 2 to power of t. Okay, so let us illustrate this one using the same example that we used in the previous example. So we simplify the notation of the word so that we can use Ka up to L. So we convert this one into just character only, alphabet character. Okay. So when we look at the query, given the query, this one, okay, in most cases, we start with a query because query is the one that we are looking at. We want to retrieve all the document based on the query, right? So given the query Q, A, B, D, N, so the number of possible pattern that we should be retrieving will be 2 to the power of 4. So basically we have 16 pattern. But some of the pattern not exist. So it could be less than 16. Okay. So we start with a single term first. So we set A, B, D, and N. And then we look at the existence of this subterm term set in the document. So these are the document that consist the term A, B, D, N. Okay, so since all of these term set exist, so we will double check again for AB. Okay, so this is for the AB, and then we check again for AD. Okay, and then AN. Okay, so we have AD and for the N we do not have because none of these consists A and N together. So that's why this one is skip. So we only have up to here, and then we check again B with the D, and then B with the N. Okay, and that one is this one. Okay, and then we check again D with the N. So D with the N we do not have here. So we do not have N and D. Oh, D and N. D and N. Where is D and N? We have here. No, the order. Okay, we do not have D and N, but this one has one, right? Let me check. Okay, di BD, BN, BN tidak ada. BN ada sini. Why? Let me take. A we have, B we have, D we have, and then N, and then AB, and then AD, and then BD. Okay, AN we do not have, AN we don't have. So we skip AN, and then we continue with BD and BN, and supposed to be DN. This is the N, but we have DN here. So DN we have here, and also BN, right? BN. This is D4. D4. 334. BN ada sini. BN is okay. Okay, but over here is 334. Okay, we have one more here. Oh, betul. Erase dulu. So yang missing tuh is the BN or DN. The end of the world. So we have DN, which is D4. So this is SDN. So all together we have 11. Okay, so we have AB, BD, BN, lepas to DN, and then after that we continue with ABD, ABD because we combine these two, and then we combine these two. Okay, so betul. Yang ini yang missing tuh. So we have all 11. 3, 3, 4. Okay? Are you following me? So once we get all this set of terms and also the number of document here, so we can say that the most frequent term set is D, followed by BD and B. Okay? So, but we need to define what is the threshold here. We can say that the number of document should be less than 2 or 2 or more, or no, 2 or less or 3 or less. So we can consider that one. So when we try to look at the term set, so normally we will look at the n term here. So in here we start with 1 first, and then we start with 2, and then we set 3. Okay, so we always start with one term set and then followed by two term set and then followed by three term set. So that is what we call the n term set. Okay. Okay, let's suppose this capital Ni be the number of document which consists this term set. So we can set a threshold here to say that if that term set is frequent or not, depending on what is the value that we want to have for this one. Okay, and this also implies that the n term set is frequent if and only if all the n-1 term set is also frequent. For example, if you have three term set, okay, three character frequent, so that means the member of that, which is the two term set, will also be frequent, and thus one term set also frequent. So that's what the meaning here. So the frequent term set can be used to reduce the number of term set to consider with long query. So this one can be used to reduce the number of term set. Okay. Okay. For example, we set the threshold here to be 2. So that means if the number of document is 2 or more, that means that term set is frequent. Okay. So we start with this query, ABD, then of course we will have SN here. Okay, so ABD all have more than two document, but SN we only have document 4. Okay, so this is not frequent. Okay, so this is one term set. We continue with two term set. So with the two term set, we combine this, and then this and that, and then this and this. So for AB, we only have one. So SAB, we only have one, document 1. Okay, because this and this. And then for AD, we have 2, 1 and 2. For BD, we have 1 and 3, and then 4. Okay, so that means this is not frequent, this is frequent, because we set the threshold to be 2, right? Okay, and then the next one will be 3 term set. So 3 term set, if you go back here, the 3 term set is this 2, but they are not having 2 or more document consisting them. So our term set is only up to here. We stop here, then there are no frequent 3 term set, then we stop. So these are the frequent term set that we have: A, B, D, AD, and BD. Okay, so we use the threshold to reduce the number of term set that we use. So this is 5. Initially we have how many? 11, right? So this is all 11. So by setting the threshold from 11, we reduce to 5. Okay. Any questions so far?
Yeah, doctor.
Boleh ya? Okay, now we define the weightage for this term set, because in the previous lecture we take individual index, right? So now the weightage for the term set we can compute using the same formula here, but instead of using individual index term, now we are using term set. Okay, the formula will be the same, but we are looking at the here, this formula here. So this one referring to the number of times the term set exists in document J, and this is referring to the number of document that consists term set, that particular term set. Okay, so we use the same formula here. So coba kita tengok contoh here. So we have query A, B, D, N, and we are looking at the this is document A. So if we look at the weightage of A in document 1, so A in document 1 we have 1, 2, 3, 4. Okay, so 4 times, so that's why we have 4 here. And then but A exists in 2 of the documents, so we have 1 and 2. So that's why we have 2 here. Then we get this. Okay, so that one is the weightage of A in document 1. Okay, let's test something else. Okay, let's test this AB. So this is with respect to document 1, right? So AB, how many times? 1, 2. AB. Okay, so that's why we have 2 here. And then the only document that has AB will be only this one. So we have only one. So we have this calculation. Okay. Any question? So they are similar to what we have before, but now we are looking at the occurrence of the term set instead of individual term that we have. Okay, if you look at the weightage of that term set in the query, so in the query, so basically if we try to find the weightage of A in the query, so we apply the same formula here. So this one is still the same, but this one is 1 lah. Okay. And similar to this, if we find the weightage of AB in Q, so this one is only 1 time. Okay, so that is the same for calculation that we use. So since we know that both document and query are represented by a vector, okay, so to rank the document with respect to the query, we will use the same formula here. So one is looking at the vector of the document, and the other one is the vector of the query. Okay, and divide by the length of the document and the length of the query here. Okay, so for term set that are not in the query, then we set the weightage to be 0. Okay, so this is just calculating the what? The length of the document. So this one we have gone through in the previous lecture, right? Okay, but for this one, we will only consider this. Okay, and this is with respect to the ABDN, single term. Okay, so now we go back to here. So if we do the calculation, only this will give you non-zero. Okay, so this is the weightage of thing. Oh, yeah, the same calculation. So these are the non-zero because yang the rest two is zero because this end does not exist here, and then this bn dn. So as long as you have n inside, so the weight of that particular term will be zero. So we will only count this 1, 2, 6, and 7. So 7 term set will be considered. Okay. So this is the term set with respect to, no, this is the weight of the term set with respect to the document. Okay. Now we want to know how do we compute the weightage of each of the term set with respect to Q, which is your query. So this is similar because very simple. The occurrence of A, B, D will be 1, and then AB one time, AD one time, BD one time, and then ABD one time. Okay. So once we get this, the weightage of the term set in the query, then we can simply use the cosine ranking function. So basically, we just multiply the same the weight for the same term set that we have. So this is this. This is for the D, A, B, A, D, B, D, and A, B, D, and divide by the length of the document. Okay. So the length of the document will only look into the single term used in the query. So this is your distance. Okay. Any question? Okay. So as you can see that we can and there is a duplication here. Okay. So we look at, if we see A here, we also have AB here, and also we have ABD. Okay. So this A is a subset of AB. AB is a subset of ABD. So they said, why not we just take this one only? Because we say that this is frequent term set if the n minus 1, okay, this is 3. So 3 term set is frequent. So that means 2 term set and 1 term set also frequent. So what they want to do now is to simplify the calculation by not including the A and AB. We just consider ABD lah. Okay. Okay. So for that reason, we introduce this closed term set. Okay, the concept of frequent term set allows simplifying the ranking computation by not including the subset. Okay, so we look at the notion of closure here. We define. So the closure of the term set S is the set of all frequent term set that co-occur with the term set in the same set of document. Okay, so given the closure of Si, the largest term set in it, the largest term set in it is called a closed term set. So we no need to count for the subset. So for example, we formalize this. Okay, let di be all the document that consists the term set si and is frequent. Okay, and let this be a set of composed of the frequent term set that occur in all of the documents. So that means this is all the term set that consists of this all of the document that we have, which is the di. Okay? So for that reason, we can define that the closed term set, which is this symbol, satisfy the following property in which there won't exist a term set that belong to this such that this is smaller than the closed term set. So that means we will ignore all the subset of the closed term set. Okay, so for example here, if we only have D, then the closed term set is D. If we have BD, so that means we will remove B because B is subset of BD. So we only take BD. Similar to this one, we don't consider A, we just take AD. And then similar to this, we just pick the biggest one. Okay, so by having this closed term set, we don't have to compute for the weightage of this single and two term set. We just consider the closed term set only. Okay, so this is because we want to reduce the computation. Okay, so if you look at the same formula that we have, okay, so if you look for finding term set, finding term set, normally we start from here. So it's better to have this table. So if you look at this one, this is similar to this, right? Okay. So that means we take A and AD, and we only take the biggest one. And next one is this one. This and this. Because they have the same document. Okay. So we take B combined with BD. Okay, B and BD. Okay. So we have BD. Okay, next one is we have D. Okay, so for D, we only have one. Okay, so that one is okay. And then we have D1 and D1. D1 and D1 here. So that one is AB and ABD, right? So we have ABD, and then we have D4, and then D4. So we could combine A, B, N. Don't have here. Oh, we don't consider the N here because N do not have in document 1. So we will ignore this. Okay. So we have that one, and then we have ADA. ADA. So ADA here. This is similar to this one, but in different order. So this one is similar to this one, and then this is similar to this one. Okay. So when we look at the final term set, this is what we get. So that means from all of this, okay, we just now we have 7, right? So we have 7. So from 7 we reduce to 4. So 4 only. Okay. So when we compute the ranking, then now we only consider 4, only 4 of them. Okay. So when we apply both the closed term set and also the frequent, for example, here, okay, let's suppose we say, okay, the minimum frequency threshold is 2, and then we are looking at the closed term set. Okay, so over here, okay, we don't look for this D1 and D1 because they only occur one time. Okay, and are similar to D4 and so on, because they occur only one document, because we have set the minimum frequency threshold. Okay, so by that we eliminate this term set, do not consider them, and then from there we build this based on what is left. So for example, let me change the color. So we D1 with D1, and then B with this, and then this one alone. Okay. Oh, yeah. Okay. So any question? So that means from 7, we can reduce to 4 if we use the closed term set. Okay, closed term set. And then we reduce again to 3 if we specify the threshold of frequent term set. Okay, so by having this, then we can simplify the calculation that we have. So now we only have 3 term set. Okay. Any question? So basically the foundation for this one is going back to the TF-IDF lah. So it says that instead of using index only, you use term set in order to consider for your ranking. But the problem with this one is we need to be careful to filter or to select which term set is valid to be included. So very, very critical in selecting them. Don't make mistake there. Once you make mistake, then your whole calculation will be wrong. Okay. Any question? Okay, let's do some exercise. For example, okay, we go back to this one here. Okay. Okay, we go back to here. Okay. Okay, let's suppose I change my query to be what? To be what? I need to capture here first. Okay, let's suppose I change this one to BD only. BD. Okay, let's suppose I change to BD only. So from BD, so you have B, and then you have D, and then you have BD, right? So basically, we only consider this, and this. The rest we don't consider. So when it comes to only BD, so we are looking at this to be the term set, which is BD and also D. So that means we only take this D and BD. And for the calculation, it will be the same here. Okay, okay, I think I got exercise. Okay, let's do the ranking for the document 3 lah. Okay. So for document 3, we have, let's say, so for document 3, we have what? G, J, K, G, H, B, D, B, D, B. Okay. So let's suppose we have this. We will duplicate this one. And let's suppose our query is GHB. Yeah. Okay. So what is the weight for G in Q and H, and also for the B? And this is the GH. This one is GB. And then HB. And then GHB. Boleh nampak?
Prof,
Yes.
dia punya query ini ikut yang dokumen tuh kah ataupun dia kena bagi itu?
All the query is given.
Query is given, okay.
Yeah, so you have document 1, 2, 3, 4 lah. So this is document 3 kan. Okay. So the
So meaning yang sekarang kita buat nih, Prof, dia punya query kita tukar.
query tukar and document pun tukar.
Oh, oke.
Okay. So yang document itu kita based on yang dalam example itu lah. So dalam example itu we have GJK, GH, and then BD. So di sini kita patut ada GJK, GH, BD. Okay. Okay, now we have GHB. This is our query lah. Okay. So GHB, so all this is one lah. But we have to look at G ini exist in berapa document. So we have to copy this one. Okay, so di sini berapa? Kita punya G. So G exists in two document kan? Okay. And then H. Two. Right? And then B. We have 1, 2, 3. We have 3. And then for the GH, we have 1, 2. 2 juga kan? And then for the GB, so we have 1, right? And then for HB, we have 1, right? And then for GHB, we have 1. Okay. So this one we calculate lah. Can you assist me to calculate this one?
Dia punya formula apa sudah tahu, Prof? Yang tengah-tengah nih?
Yang mana satu?
Yang 1 plus log 1 tuh. Yang 1 di log tuh apa dia formula? Boleh Prof balik kasih
Yep.
tunjuk. Ya.
The formula is this one. So dia log base 2 lah. So log base 2, the frequency of the term set in that document times log base 2 1 plus this one lah.
So maksudnya Prof, let's say dia punya dokumen ada 3 dia punya B.
Okay.
Lepas itu query ada 1 dia punya B. So dia punya frekuensi of term set tuh kita set 1 saja.
Yeah, yang itu kita refer to yang sini kan. So if we are looking at the query, if this is query, so this is the frequency of that term set in the query. Kalau document. But this one is always the number of document that consists that term set. So now we are calculating the weightage for the term set in the query, right? Right? So when that thing happen, so this one should be what? So
frequency term set.
So that means this one is actually the number of occurrence of G in Q. So I put Q here. This is only calculating the weightage of the term set with respect to the query. So semua satu lah. Semua ini satu.
Okay. The next log for over2 dari mana tadi tuh? G.
This?
Yeah.
Okay, this one is the IDF. So this one is referring to the number of document that consists G, which is this one, 2.
Oh, okay. So for 2 yang total G kah? For total number of document.
Yeah, total number of document consisting G.
And then yang 4 yang di atas 2 tu total document.
Yes, total document always 4 kan?
Yeah.
Dalam our example.
Okay.
Okay, so need to calculate this one. What is this one? Let me try Google. Berapa jawabannya? 1.58 kah?
Iya, sama Prof.
Okay, so 1.58 sama juga kan? So yang ini sama juga nih, kan? Yang ini, so we have 3.
Kalau 3 1.22.
1.22. Okay. Yang ini sama saja kan? 1.58 kan?
Iya, Prof.
Pas itu yang ini?
Yang itu 2.322. 322.
Yang ini sama.
Sama.
Yang ini pun sama. Kan? Okay, so this is the weightage of all those in the query. So now we have to look at in the B, no, in the document itself. So we have, so this is in document 3. So the rest is still the same yang for the number of document. So this part is all the same lah. So we need to change di sini lah. So di sini G exist berapa time? 1, 2 kali kan? And then H 1 time, B 3 times, and then GH 1 2 1, GB 2 kali kan? And then HB berapa H? 1. Just 1 saja lah. GHB only 1. So kita kira ini berapa? Is this 2.44? Paham kah? Sama calculation kamu. So this is still the same. So this is 3. Oh, tadi salah.
Yang first to 3.17.
Yeah, the first one is 3.17. Because dia only 2 kan. So di sini baru ada 3. 3 and 3. So 3 and 3 we have 3.16 kan?
Yeah, Prof.
3.16. Then we have 1, 2, which is similar. And then this is 1, 1 similar, 1, 1 similar. This is 2, 1. So 2, 1, 6.00 kan?
Saya dapat 4.64.
No, 4.64 dapat 2, 1, 2, 1. Oh yeah, 2, 4.64. Okay, so that is berapa? 4.64 kan?
Yeah, Prof.
Okay, so the length of the document berapa? So we look at this one only lah, GHB. So the length of the document will be looking at G and also so we look at GHB. So we take the square root of this kan? So what is the document length? So what is the document length here? For the document 3.
Saya dapat 4.75.
Berapa?
4.75.
4.75. So how you get it? You take the square root of 3.17 square plus 1.58 square plus 3.16 square kan? Ini kan?
Yeah, Prof.
Okay, so we have that. Okay, so we have 4.75. Okay, so for us to compute the weightage, the distance between these two, so basically we multiply this with this and with multiplication of this and that and so on. Okay, and divide by 4.7. Okay, so if we look at the ranking here, or the distance between the query and also document 3, So basically, we are looking at 1.58 times 3.17, right? Plus, so all together is 2 plus 2.32 times 2.32 divided by 4.75, right? So these are the length, the distance between these two, where we need to compute for 7 weightage. Okay. So this is for the basic one. Okay. Now let's consider the close. Okay. So we managed to compute the weightage. So this is the most time consuming one. Okay. Now let's suppose we want to compute only the close term set. Okay. So for the toss, for the knee, we have to look at, we need to build the nail. So first we have what? So first we have G, and also we have H, and then we also have B, B, and then G, H, GB, and then HB, and then GHB. Okay, so we are looking at this. Okay, so now G exists in what document? Based on this. So G exists in document 2 and 3, right?
Yeah, 2 and 3.
Okay, and H? 2 and 3, right?
2 and 3.
2 and 3. B, document 1, document 3, and document 4, right? GH, GH, GH. So document 2, document 3, right? GB, GB. We have only in document 3. HB. So HB we have document 3. And last one is GHB, document 3. Okay. So from here, we can produce what? Okay. So we take this, we color first one, and this, and this. So all these three, G, H, and GH. So this one will be GH only, right? and then this one will be 1, so B only, so B go to B, and then the D3 here, so all become so GB, HB, GHB, so this one will go to GHB. Okay, so now become three only term set, right? So for using that one, so we will be using only 3, so which is the GHB and GHB. Okay, so based on this, yes,
Prof,
yes,
yang closure nih, contoh GB, HB, GHB, make sure dirang exist dalam dokumen yang sama, Prof.
yes, we can see from here.
Ya mesti
We,
oke.
yeah, so we tengok mana set of document tu yang sama, so we combine them lah.
What if, Prof, kalau GB itu dia exist D2 dan D3?
D2 GB.
Ya, let's say GB itu dia exist dalam D2 and D3. What if? Dia
Okay.
dia
So
masih boleh apply kah closure?
in that case, the combination of this will be different though. You're saying that if the GB is 2 and D3 kan,
Ya,
kan? Then dia tidak akan masuk dalam sini. Dia akan masuk dalam sini yang merah.
so
Tapi
dia boleh jadi
uh,
GHB?
so dalam case ini dia masuk JSB saja lah. Okay? Tapi this one will affect this one because if we assume that they are in this one GB, then it doesn't make sense sudah di sini. So dia mesti ikut yang the actual occurrence of the document. Then baru make sense. Tapi in this case, this is 3 lah kan.
Oke.
So di sini kita ada 3 sudah. So that means the document length will be the same. So we need to compute what is GH and B. So the B is the GH is 1.8 times the GH. So that is the GH, and the B is 1.22 and 3.16. So 1.22 times 3.16. Then we have the GHB. GHB is 2.8. So it will be the same. Okay. So this is using the closed term set. So we only have 3. So simplifying the calculation. Okay. So the third one, how do we reduce? Okay, we say that the frequent term set is frequent if it exists in, if we set the threshold is 2. If the threshold is 2. Okay, so if the threshold is 2, so that means this one is no longer frequent, right? Because they only have 1. So we will remove this. We'll remove this, and we only have G, H, and B. So our calculation will include only this. Okay. So notice that from 7 here, so we can reduce if we introduce the closed term set. So this one is based on the the closure lah. And this is based on setting the frequent threshold. Okay, so this is without anything, we include all. And then this one is if we introduce closure, we look into the closure, so we reduce from 7 to 3. And then this is if we say we want to limit frequent term to be those having 2 or more document only. And then we don't include the D3 here, so we only have 2. Okay. Any question? Boleh follow? Boleh?
Ini mau praktis lebih nih.
Yeah. Tidak, nanti I share this one. So you start with this. You start with this one. Then you really need to go through this one sendiri lah. Then you know what's going on lah. So normally the exam should be something like this lah. So we have this. So dia bilang consider this. Bilang compute the so compute the distance between Q and D3 using closure and so this is soalan untuk yang inilah. So given this 4 document and then the query and then the G. So they ask you to compute the distance between Q and D3 when using closure and threshold of frequent term set equal to 2. So basically you do this first. You need to compute all the weightage, okay? And then once you compute all the weightage, then you need to do the closure. And then once you get the closure, then you can eliminate the one that do not satisfy the frequent term set, which look at the threshold. So your final answer will be this one. Right? Any question? No. Yes. Yes. No. Okay. Oop.